Hi everyone. So we spent all last week talking about rules of exponents and properties of exponents and how they work when you're simplifying an expression. Today we're going to start talking about what's called rational exponents. And before you get terrified, rational is just a scary word for fraction. Okay? So today we're going to start talking about what to do when your exponent is a fraction. Not that fractions are any less terrifying, but you're going to see that all of those same rules from last week apply this week. It's just a matter of what it means to have an exponent of, say, like 1/3 or 1/2. What does that mean for your problem? Okay? So, perfect slide. What do these mean? 16 to the power of 1/4. Well, remember, powers are all about multiplication. Okay, so that's the one thing I want you to keep in mind, is that everything we're doing focuses on multiplying. When I say 3 to the 4th power, that's multiplication. That's 3 times 3 times 3 times 3. So when I say 16 to the 1/4 power, that really means I want you to take 16 and split it into 4 equal factors. And that word factors is important. Factors means numbers that are multiplied together. So, not using division here, okay? And this is the thing that probably messes the most people up. Because I see a lot of people saying, oh, 16 to the 1/4, well, 16 divided by 4 is 4, so it must be 4. Well, what I'm really looking for is what times itself 4 times, or in other words, what to the power of 4 would equal 16. And the way you find that is by making a factor tree. So a factor tree, again, is all focused on multiplication. So I'm looking for two things that multiply to make 16. Let's say 2 and 8. Well, 2 is what we call prime, meaning I can't break 2 down any further without just doing like 2 times 1. So 2 is as far as I can go. 8, I could come up with some other factors for. Think to yourself, what times what makes 8? Well, 2 times 4 makes 8. Again, 2 is prime, 4 is not. 4 I could break down and say, oh, well, 4 is equal to 2 times 2. Now both of those are prime. So you'll see that 16 is equal to 2 times 2 times 2 times 2, which is really 2 to the 4th power. So 16 to the 1/4 power, meaning 16 broken into 4 pieces, is just 2. Okay, because all of the pieces are equal to 2. So 16 to the power of 1/4 is equal to 2. Because if I had 4 2's multiplied together, that would make 16. Okay, I think I've said that same thing like 1,000 different times, but hopefully that's making sense to you, one of the thousands of ways I said it. So let's try this. 27 to the power of 1/3. Well, again, I'm going to make a factor tree and think about what multiplies to make 27. Well, that'd be 3 and 9. Okay. 3 is prime because, again, there's nothing that multiplies to make 3 besides 3 and 1, but 9 is not. And then 9 could break down to be 3 and 3. I guess I should have done that off to the side. 3's are both prime. So 27 is equal to 3 times 3 times 3. So I've split into 3 different factors, which means 27 to the power of 1/3 is just equal to 3. Let's try the same thing for 32. I'm going to zoom in a little bit so that you can see it. 32. What times what makes 32? Well, 8 and 4 make 32. Neither one of those are prime because 8 can break down into 2 and 4. Now 2 is prime, 4 is not. 4 can break down to 2 and 2. Those are both prime. And 4 breaks down into 2 and 2. Those are both prime. Okay, so 32 is equal to 2 times 2 times 2 times 2 times 2. which means 32 to the power of 1/5, which is really saying take that 32 and break it into 5 pieces is equal to 2. Because that's what we did. We broke it into 5 equal factors. Okay? So again, you could almost read this like a reciprocal. 2 to the power of 5 instead of 1/5. 2 to the power of 5 is equal to 32. So if you're reading it backwards, that's how you would read it. Okay, 625 to the 1/4 power. This one might be a little tricky because I don't expect you to have your factors of 625 memorized off the top of your head. But hopefully you would say, well, I know 5 goes into that, so let's divide by 5. And you're going to find that it's 5 times 125. Well, 5 is prime. 125 is 5 and 25. 5 is prime. 25 is 5 and 5. And so again, you'll see that 625 broke down into 5 times 5 times 5 times 5. So 4 equal factors. So 625 to the power of 1/4 is just equal to 5. Because when you break it into 4 equal factors, that's what the factors are. Okay? All right, these are going to get a little trickier. So I would take a minute right now and make sure that you really digested what we just did. Okay, so let's say I took negative 27 to the power of 1/3. What I would do in this situation is ignore the negative, okay? So for now, I'm just going to think to myself, what times what makes 27? And I think we actually did that one on the previous page. Yeah, I'm not even going to break it down again. We found that 27 to the 1/3 power was equal to 3. And again, we did that in the last slide, so you can look back at that if you need to. Now, this is negative 27. So does it make sense that negative 27 to the power of 1/3 would be negative 3? And so what I want you to ask yourself is it true that negative 3 times negative 3 times negative 3 equals negative 27? Okay, so let's see. Negative 3 times negative 3 makes positive 9, and positive 9 times negative 3 makes negative 27. So that's correct. Okay, so negative 27 to the power of 1/3 is equal to negative 3. Okay, so let's see if that rule always works. Let's take negative 64 to the 1/2. And this one I'm going to do really without a factor tree, mostly because we haven't talked about these kind with a factor tree yet. But when I say 64 to the power of 1/2, what I'm really saying is take 64 and break it into 2 equal pieces. Now, you're going to call me out on this right here because I'm not going to do a complete factor tree. But think about this. 64 broken into 2 equal factors. What times what makes 64 where the 2 factors are exactly the same? That'd be 8 and 8. Okay, so I know 64 to the power of 1/2 is equal to 8. So is it true that negative 64 to the power of 1/2 is equal to negative 8? Because that's what we did up here, right? So, let's see. That would mean that negative 8 times negative 8 was equal to negative 64. Do you see a problem there? Negative 8 times negative 8, 2 negatives are always going to make a positive. So this is not a true statement. This does not work. Okay, so let's see. Why does it work here? Here's why. Okay, about that. What you're going to find when you're doing these is if the fraction has an odd denominator. So like the 3. That's telling you you're breaking into 3 pieces. That plays nicely with negatives, because if you have an odd number of negatives, your answer is still going to come out negative. Okay, so if you have a problem like this one, if this is negative and your number is negative, all you have to do is raise it to the power of 1/3 and then slap a negative on your answer. But if the fraction has an even denominator. So like the 2 here, and you're breaking into an even number of pieces. An even number of negative factors is never going to make a negative number, right? Because 2 negatives make a positive, which means 4 negatives would make a positive. 8 negatives would make a positive. So anytime you're splitting into an even number of pieces, you can't possibly make a negative number out of that. So this is a no solution. Whereas this one was just -3. So there's a big difference between this, and you really have to watch out for that. Okay, you can't ever take a negative number and work with a fraction that has an even number on the bottom. Okay, let's try a couple more. And this is what I meant on the last slide where I said, oh, you're going to call me out for not doing a complete factor tree. You'll notice that when I did the factor tree for 64, I stopped at 8 and 8, even though that factor tree could be continued. Okay, I could have taken the 8s and broken them down further. It's okay with me for you to take shortcuts like that. I'm going to show you these without taking any shortcuts so that you know what to do if you don't catch the shortcut. Okay, but you'll see what I mean in just a second. So let's take 100 and make a factor tree. And if you were in class with me, I would ask you to call out something that multiplies to make 100, but you're obviously seeing me in video form here. So what times what makes 100? Well, let's go 2 and 50. Well, what times what makes 50? 5 and 10. Notice the 2 is prime, the 5 is prime, and 10 is made up of 2 and 5. So if I was going to write 100 out as a prime factorization, meaning what times what times what times what makes 100, I would write 2 times 2 times 5 times 5. Okay, but what I'm looking for is 2 exact factors. I'm looking for something times something. And again, I know that I'm looking for 2 factors because my fraction was 1/2. So that means I'm splitting into 2 pieces. So something times something that equals 100. Again, I'm hoping most of you can look at that and go, oh, well, 10 times 10 is 100. I didn't even have to do that crazy factor tree thing. Okay, but in case you weren't able to do that, let's see. If I was to take these 4 factors and try to put them in these boxes so that each of the boxes was exactly the same, does it make sense that each one would get a 2 and each one would get a 5? Because I want my 2 boxes to be exactly the same. Which means my boxes are actually equal to 10. 10 times 10 is equal to 100. Okay? And therefore, 100 to the 1/2, I'm going to switch my color real quick. Is equal to 10. Okay? Because when I split 100 into 2 equal factors, each of the factors comes out to be 10. So again, some of you may have looked at that and known that right away. Others of you may have had to actually factor it all the way out and then put the pieces back together. So let's take a look at 144. And again, if you feel like you know the answer already, just hold your thought for a minute. I want you to see what to do in case you don't know the answer. So let's say I look at 144. I might... 144. And I'm going to break that up. Well, a lot of us, when we start our factor trees, we start with the most basic number we can think of. So let's go with 2. Now, 2 is prime, but I say to myself, 2 times what is 144? So, hello, Mr. Calculator. What's 144 divided by 2? That'd be 72. And then I think, okay, does 2 go into 72? Sure it does. So 2 times what makes 72? That'd be 36. Should I give myself some more space here? Okay. So does 2 go into 36? Sure it does. So 2 and 18 make 36. Again, 2 is prime. 18 is not. Okay. So here I get 2 and 9. 2 is prime. 9 is not. Now 9, I can't go with my 2 anymore because 2 does not divide evenly into 9. But what times what does make 9? 3. So I ended up with 4 2s and 2 3s. And again, my problem, way back up there at the top, was 144 to the power of 1/2, which means I'm looking for 2 boxes, or 2 factors, that multiply together to equal 144. Well, look at your factors. If you have 4 2s, that means each box has to have 2 2s. And then I have 2 3s, which means each box gets a 3. And then you're multiplying those pieces back together. Sorry, I kind of crammed those in there. So 2 times 2 times 3, let's see, that's 4 times 3, which is 12, times 12 is 144. So there is your answer to 144 to the 1/2. 144 to the 1/2 would have to equal 12, because when I split the factors of 144 into 2 equal groups, each group is equal to 12. And that's what the question is really asking, is when you take 144, when you take all of the factors of 144 and split them into groups, or split them into 2 groups, what is each factor equal to? Well, each factor would be equal to 12. Okay. Let me slide all this stuff back out of the way, go to the next example. Get out of here. Okay, so 1 to the 1/6 power. This one's a little tricky. Please don't take the time to try to figure out a factor tree for 1, okay? You'll be there forever. What I want to know is what times itself 6 times would equal 1. That's what this is saying. What multiplied by itself 6 times would equal 1? It doesn't matter how many times you multiply. The way you multiply to make 1 is 1 times 1 times 1 times 1. So 1 to the 1/6 power is just equal to 1. Okay, so your rule there is 1 to the power of anything is equal to 1. So I could say 1 to the power of 27. Well, 1 times 1 times 1, 27 times, is still going to equal 1. Same rule applies for fractions, okay? So 1 to the power of 1/6 is going to equal 1. 1 to the power of 1/5 is going to equal 1. Because if you multiply 1 any number of times, it's still going to equal 1. Okay, so that should be like a shortcut for you. 1 to the power of any fraction is going to equal 1. Okay. Let's look at the next one. You've got a fraction raised to the power of a fraction. Is there anything more terrifying than that? Well, all you're going to do is treat these separately. You're going to take the 27 and the 125 and raise them both to the power of 1/3. So I think we've actually done, well, no, we haven't quite done both of those. So I would take the 27 and do a factor tree. So what times what makes 27? That'd be 3 and 9. The 9 is 3 and 3. So 27 to the power of 1/3, if you break it down into 3 equal pieces, is equal to 3. And then let's do the same thing for 125. 125 broken down is 5 and 25. 25 is 5 and 5. So there's your 3 equal factors. So 125 to the power of 1/3 is just equal to 5. So then I take my answer for the 27 and answer to the 125, that'd be the 3 and the 5, and just write them back as a fraction again. So final answer here would be, well, let's see, is it 27 over 125 to the power of 1/3 is equal to 3 over 5. So all I really did was the 2 pieces separately. I did the 27 to the 1/3, I did the 125 to the 1/3. Broke them both into 3 equal pieces and then put them back together as a fraction. So don't let the fraction scare you, it's just like 2 problems combined into 1. Okay, so here's the problem. So far I've given you really nice numbers. I've given you numbers that just divide up perfectly, where if I ask you for 3 equal pieces, you make a factor tree and it comes out to 3 equal pieces. Okay? So when they don't split evenly, because it's actually pretty rare that they do split perfectly, you just type them into a calculator, and your calculator is going to give you a decimal approximation. So what you want to make sure when you type these into your calculator is that you put the fraction part in parentheses, okay, so that your calculator understands it's a fraction. And remember, you enter a fraction with division, so 1/3 is like 1 divided by 3. And if the number at the bottom, so the base would be like this number down here, okay, if that's negative, that needs to be in parentheses too. Because remember I told you way back when that if you walked out of my class remembering one thing, it would be that negative numbers being raised to powers have to be in parentheses in your calculator. Okay, so for the first one, if you type in 10 to the power of 1/3, and again what I would actually type in is 10 to the power of parentheses 1 divided by 3 parentheses, you should get 2.154. And again what that means is if you did 2.154 multiplied by itself 3 times, or in other words 2.154 to the power of 3, it should come awfully close to 10. Now it's probably not going to come out exactly because this was a rounded number. Okay, that 154 actually continued, and I'm not sure what the decimal was, but that's what you're really saying, is what times itself 3 times would give you 10. So 52 to the 1/7 power, take a second, try that on your calculator, make sure you can get it. You should get about 1.759. Again, make sure your 1/7 is in parentheses. And then for that last one, negative 12 to the power of 1/6. Again, make sure that negative 12 is in parentheses and the 1/6 is in parentheses. The problem you're going to run into, anytime this number down here is negative, remember we talked about this a few slides back, if your number on the bottom is negative and this is even, that's when trouble starts. Okay, that's when you can't take a negative number and split it into an even number of pieces. Okay, this one you should get a no solution. You should get an error of some kind, depending on what calculator you're using. If you did not get an error, you didn't type it in correctly. Okay, so if you're having trouble with the calculator, please talk to me in class tomorrow. All right, finally, equation solving. Remember when I say solve, what I'm really saying is find the value of x. So like here, what I'm looking for is what raised to the power of 1/8 would give me 7. Anytime you're solving, okay, and solving is kind of your key word, you're working backwards. You're doing the opposite of everything. So in this case, the opposite would be raising to the power of the reciprocal. And remember, reciprocal is when you flip the fraction over. So here, to get rid of the power of 1/8, I want to raise this to the power of the reciprocal of 1/8, which is really 8 over 1. Well, 8 over 1 is really just 8, so all I'm doing is 7 to the power of 8. Over here, remember that when you raise a power to a power, you're multiplying, and when you do 1/8 times 8 over 1, that's really going to cancel that whole thing out. Okay, so you're left with just x. That's why you did that. Now, 7 to the 8th power, give me just a quick second here. Oh, sorry about that. Dropped my stylus on the screen. Okay, 7 to the power of 8 is 5,764,801. Okay. On that next one, remember that before you get rid of that 1/3, if you're working backwards, you need to get rid of that negative 10 first. It's just like if I gave you the problem negative 10x squared equals something something. You would have to get rid of the negative 10 before you do anything else. So I'm going to divide by negative 10, divide by negative 10. I end up with x to the 1/3 equals negative 4. Whoops, negative 4. And then, to get rid of that power of 1/3, that's where you're going to raise to the power of the reciprocal. And again, the reciprocal of 1/3 is 3 over 1, or just 3. And back here, notice I put that 7 in parentheses. I always do that, but it wouldn't have mattered if you didn't do the parentheses on this one. On this one, it would matter. Okay, so when you're raising a negative number to a power, you have to put it in parentheses. Have to put it in parentheses. So I always do it just to be safe. That way I don't have to worry about, like, do I need it, do I not need it? But in this case, very important that you put the -4 in parentheses. -4 to the power of 3 is going to be equal to -64. So that means if you took, just looking back at this step, if you took -64 to the power of 1/3, you would get -4. Okay, so that's what you're really finding there, is what the value of x is. Okay, I've thrown a lot of stuff at you here. So I've thrown a lot of stuff at you. Rational exponents is a very big topic, the fraction exponents. And so what we've done here is just a little bit of practice with each different type of problem I could give you. But you're going to need a lot more practice. So for tonight, what I'm going to give you for homework is Lesson Master 7-6B. And pay attention in your homework packet, because I believe there's a page in your packet that we skipped. We are not doing 7-2 and 7-3B, so make sure you're looking for a page that says 7-6B. And for now, I just want you to do the odds. Now, we probably will come back and do the evens after class tomorrow, but for tonight, what I want done are the odds. So when you come to class on Wednesday, you should have the odds done from this 7-6B. Okay? And then also, last week Friday, I assigned you a Brain Genie assignment. And if you haven't logged into that yet, you should look back on last week Thursday. That's actually where I posted it in Blackboard. But of course, we didn't have school Thursday. So, Brain Genie from last week Thursday was supposed to be due on Monday. And then, of course, you got an extension there because we didn't have school Monday. So, I'm going to make that also due on Wednesday. So make sure that's done when you come to class tomorrow. And then quiz tomorrow too. And the quiz does not cover these rational exponents. I repeat, there are no fraction exponents on your quiz. For tomorrow, it's all just stuff from that flip book. And then the Brain Genie assignment is also meant to get you ready for that quiz. So I would actually focus on that stuff first. Make sure you're ready on that. And then go back to the 7-6B, which goes with these notes for tomorrow. Okay? I will be in my room tomorrow if you do want to stop down and get some clarification or some help on any of these problems. And we will spend plenty of time going over this tomorrow as well. So let me know if you have any questions.